In this massive rush to automate everything in software development, we're giving AI some serious power. But what happens when that trust gets completely broken? Well, today we're going to dive into some fascinating research that uncovers a brand new and super subtle cybersecurity threat. This is a big one, folks, because it's a threat that can fool even the most advanced AI out there.
I know what you're thinking. That sounds impossible, right? How could a couple of super simple commands trick a state-of-the-art AI? An AI that's supposed to be protecting our code. It's like a high-tech heist movie, but the master key is hiding in plain sight. So let's pull back the curtain and see exactly how this whole thing went down. Okay, so first, let's set the scene here. Think about all those big, popular open-source software projects. They are quite literally the backbone of the modern internet. But the people who maintain them, they are absolutely swamped. They're just drowning in a flood of code submissions, pull requests, coming in from developers all over the globe. It's created this huge, massive bottleneck.
So to try and fix this problem, teams are getting really creative. What are they doing? They're bringing in AI assistants, like Anthropic's Claude, to act as these automated gatekeepers. And honestly, the idea seems pretty smart, right? You let the AI handle all the easy, routine approvals from developers you already know and trust. That frees up the human experts to focus on the really tricky, complex code.
And here's the rule they gave the AI. It's super simple. If a chunk of code comes from a well-known, respected expert, just go ahead and approve it automatically. Now, this rule is the absolute key to everything. See, it totally shifts the focus. It's no longer about checking the code itself, it's about trusting the author. And that, my friends, is exactly where the crack in the armor appears.
All right, so if you're a hacker, how do you get past this new AI bouncer at the door? Well, some researchers at Manifold Security decided to find out. They basically put on their black hats and cooked up this really clever plan. Their goal wasn't to hack the system with brute force, but to see if they could just, outsmart it, trick it.
And their plan follows 4 classic heist stages. It's perfect. Step 1, create the perfect disguise. Step 2, hide your malicious payload right out in the open. Step 3, just stroll right past the AI gatekeeper. And finally, Step 4, once you're inside, you activate the code.
Now, here's the kicker. The master key for this whole operation, it's not some crazy complex piece of malware. Nope, it's just 2 basic setup commands in Git. That's the version control system that pretty much every single developer on the planet uses. With just these 2 little lines, an attacker can claim to be, well, anyone they want. And in this case, they decided to impersonate the legendary AI researcher Andrej Karpathy.
And what's really wild is that this isn't even a bug in Git. It's actually a feature. The whole system was designed to be super flexible, so it lets anyone label their work with any name or email they want. The assumption was always that you'd use something else, like a cryptographic signature, to prove you are who you say you are. So the problem here isn't Git. The real problem is the AI's blind, naive trust in information that is so easy to fake.
Okay, so the stage is set. The attacker, wearing their clever disguise as a famous researcher, submits their code, their pull request. And hidden inside is the payload, a malicious script that's cleverly disguised to look like a boring, harmless configuration file. All they have to do now is sit back and wait for the AI gatekeeper to take the bait. And sure enough, the AI, Claude, sees the name Andrej Karpathy. It scans its vast knowledge base and confidently reports back. Oh yeah, this guy's a highly respected figure. And so, just like it was told, it follows its rules to the letter, and boom, it auto-approves the submission. The AI did its job perfectly, and in doing so, it failed spectacularly. And get this, the AI didn't just give it a thumbs up. It actually had the power to merge the code directly into the project's official code base. And just like that, the heist is complete. The attacker is in. Their malicious code is now a trusted part of the official software.
So the bad guy is inside the gates. Now the real question is, what's the potential damage here? And believe me, this isn't just about one little project. An attack like this can ripple outwards, causing widespread harm and affecting thousands, maybe even millions, of people who use that software.
And I want to be super clear. This is not some theoretical problem. The researchers actually went and looked. They found over 12,400 public projects on GitHub that were using this exact same AI workflow. A whole lot of them could be vulnerable to the same flawed logic. The potential scale of this problem is, well, it's just enormous.
This type of thing has a name. It's called a supply chain attack. And it's incredibly clever. Instead of trying to break down the front door of a huge, well-defended company, you just poison one of the smaller, open-source tools that they rely on. It's like poisoning the water source for the whole town. When that big company updates its software, it unknowingly drinks the poison, pulling in your malicious code. It's a way to hit thousands of targets by finding just one single weak link.
The researchers actually spelled out a few nightmare scenarios for us. Just imagine this happening to a super popular software library. Suddenly, thousands of developers who use it are infected. Or think about an internal attack inside a big company. Someone impersonates a senior engineer and just walks away with all the secret keys to the kingdom. API keys, database passwords, you name it. There's even this creepy watering hole attack where the malicious code just sits there, dormant, like a predator, waiting for another AI agent to come along and trigger the trap.
Okay, so how do we fix this? The good news is the answer isn't necessarily to build a smarter AI. It's about building a smarter, more secure process that the AI operates within. We have to stop just trusting a name on a screen and start actually verifying that person's identity. And the solutions are actually pretty straightforward. It boils down to this. Don't just trust the author's name. Instead, require commits to be cryptographically signed. Don't give the AI the power to automatically merge code. Instead, let it flag things for a human to review. And please, never let an unverified identity be the only thing that matters. You've got to keep a human in the loop for the final say.
So, to wrap up the key takeaways here. First, enforce cryptographic signatures. That way you can actually prove who sent the code. Second, make sure humans are always in charge of the final decision. Use AI as an amazing assistant, not as an all-powerful ruler. Third, treat those AI configuration files like they're critical code themselves, because they are. And finally, you have to watch what your AIs are actually doing, not just take their word for it.
You know, when you take a step back, this whole thing leaves us with a really important question. We are racing ahead trying to make AI the ultimate co-pilot for, well, pretty much all of our digital lives. But as this research clearly shows, we have to stop and ask ourselves a very simple question. Who's watching the co-pilot?